Additional Maths, Section 2, Algebra. Part 1, Linear Inequalities. Let's look at linear inequalities. A linear inequality is the same as a linear equation, except that instead of an equal sign, we have one of the following: a less than sign, less than or equal to, greater than, or greater than or equal to. Now these do not state that the sides are equal, but one side may be larger than the other. So A with an arrow pointing to the left, B, means A is less than B. A with an underlined left arrow, B, means A is less than or equal to B. A with a right arrow means A is greater than B. And A with an underlined right arrow, B, means A is greater than or equal to B. Now we can represent an inequality on a diagram. Suppose we have the inequality x is greater or equal to 2. Now we would represent this as, starting with a number line, we draw a filled circle above the number 2, and because we want all the numbers that are greater than 2, we draw an arrow to the right of the circle. If we have the inequality minus 2 is less than x, which is less than or equal to 4, we would draw this as a number line with an unfilled circle above the minus 2 and a filled circle above the number 4. Now we want the numbers that lie between minus 2 and 4, and so we draw a line joining minus 2 to 4. If we had the inequality x is less than 3, we would draw an unfilled circle above the 3 on the number line, and then draw an arrow to the left to represent all the numbers less than 3. So, a filled circle is used for less than or equal to, or greater than or equal to show that the number is included. An empty circle is used for less than, or for greater than, to show that the number is not included. The main rule for solving an inequality is almost the same as the rule for solving equations. For equations we have, as long as the same thing is done to both sides, the equation remains true. Now in general this works for inequalities, but not always. Let's look at an example. Solve the inequality 4x minus 3 is greater or equal to 2x plus 5 and represent it on a number line. Well, to solve this we start with the inequality 4x minus 3 is greater or equal to 2x plus 5. Now we want to get x on its own on the left hand side, so to get rid of the minus 3 we'll add 3 to both sides, and that gives us 4x is greater or equal to 2x plus 8. Now we don't want any x terms on the right hand side, so we'll subtract 2x from both sides. And that leaves us 2x is greater or equal to 8. Now we'll divide by 2, in which case we have x is greater or equal to 4. And that's our solution. We can represent this on the number line by starting with the number line and drawing a filled dot above 4. It's filled because x can equal 4, and we draw an arrow to the right to show numbers greater than 4. Well, the rule for solving equations worked very well this time and gave us a solution. However, there are some exceptions to the rule when we're solving inequalities that we must be aware of. Now we have the following rules for solving inequalities. The general rule for solving equations usually still works for inequalities. If the same thing is done to both sides of an inequality, it remains true. However, there are a few important exceptions. First, if we swap the sides of an inequality, we must swap the direction of the inequality signs. 3 is less than 5, but if we change the sides, 5 is greater than 3, so the inequality sign must change its direction. Exception 2. If we change the sign all the way through the inequality, we must swap the direction of the inequality sign. So if we have 3 is less than 5, and change it to -3 and -5, we have -3 is greater than -5. And the third exception, if we multiply or divide both sides by a negative number, we must change the direction of the inequality sign. So, -2 is less than or equal to 5, but if we multiply both sides by -3, we get -2 times -3, which is 6, is greater or equal to 5 times -3, which is -15. So let's look at an example. Let's solve the inequality 1 is less than 7 minus 2x, which is less than or equal to 9. Well, the first thing we want to do is we want to get the x term in the middle on its own. We'll subtract 7 from each of the sides. So when we subtract 7 from the left, which is 1, we get -6. When we subtract 7 from the middle, the 7 disappears and we're left with -2x. And if we subtract 7 from the right-hand side, we have 9 minus 7, which is 2. Now, we want to get x on its own in the middle, so we're going to divide all the way through by -2. But because we're dividing by a negative number, we must change the directions of the inequalities. So -6 divided by -2 gives you 3. We have to change the direction of the inequality because we're dividing by a negative number. So it's greater than. When we divide -2x by -2, we're just left with x. Again, we have to change the direction of the inequality. And when we divide 2 by -2, we get -1. So our answer is 3 is greater than x, which is greater or equal to -1. Or we can write that, swapping it all round, -1 is less than or equal to x, which is less than 3. Now we can represent that on the number line by drawing a filled circle above -1 and an empty circle above 3. Now we want the numbers between those two, and so we join with a straight line. Now in example 3, solve 1 is less than or equal to 7 minus 3x, which is less than 19, and represent the solution on the number line. Well, we start with 1 is less than or equal to 7 minus 3x, which is less than 19, and we want to get the x term on its own in the middle. So we're going to subtract 7 from each side. So the left side, 1 minus 7 is -6, is less than or equal to. In the middle term, the 7 disappears. And on the right-hand side, we've got 19, take away 7 is 12. Now we want x on its own in the middle term, so we're going to divide all the way through by -3. Now -6 divided by -3 is 2, but we have to change the direction of the inequality because we're dividing by a negative number. -3x will become x. Again, the inequality changes its direction. And 12 divided by -3 is -4. And so our answer is 2 is greater than or equal to x, which is greater than -4. Or we can write that -4 is less than x, which is less than or equal to 2. So we draw an empty circle above the -4 because it's less than, and a filled circle above the 2 because it's less than or equal to. And we draw a line between the two circles because x lies between those two numbers. There follows an exercise. What you can do is pause the video at this point, have a go at those, and then when you restart the video, I'll go through the solutions. Okay, here are the solutions. The first equation is 5x minus 4 is less than or equal to 2x plus 8. Now, we want to get all the numbers on the right-hand side, the letters on the left-hand side. So if we add 4 to both sides, we'll have 5x is less than or equal to 2x plus 12. Now, we can subtract 2x from each side, and that'll give us 3x is less than or equal to 12, and we can divide by 3. That means x is less than or equal to 4, and that's our answer. Now we can represent that on the number line by drawing a dot above the 4. Now the dot is filled in because x can take the value 4. X is less than or equal to 4. And we draw an arrow to the left which shows that x can take any value below 4. In example B, we've got 4 plus 3x is greater or equal to 16 minus x. Now to get all the x's on the left-hand side, we'll need to add x to both sides. That gives us 4 plus 4x is greater or equal to 16. Now if we subtract 4 from both sides, we have 4x is greater or equal to 12. And if we divide by 4, that gives us x is greater or equal to 3. And that's our answer. Now we can draw this on the number line. We put a dot above 3. We fill the dot in because x can take the value 3. X is greater or equal to 3. And we draw an arrow to the right to show all the numbers that are greater than 3. Now in question C, we have 4 minus 2x is less than 3x minus 21. If we add 2x to each side, we end up with 4 is greater than 5x minus 21. If we add 21 to both sides, we end up with 25 is less than 5x. Now, we can swap the sides. But when we swap the sides, we must change the direction of the inequality. So 5x is greater than 25. Now, if we divide by 5, we end up with x is greater than 5, and that's our answer. So, on the number line, we draw a circle above the 5. It's not filled in because x cannot take the value 5. It can only take the numbers greater than 5, so we draw an arrow to the right of the circle. In question D, we have 2x minus 4 is greater than 5x minus 10. If we add 4 to both sides, we end up with 2x is greater than 5x minus 6. Now we want to get all the x's onto the left-hand side, so we'll subtract 5x from both sides. Now that gives us minus 3x is greater than minus 6. Now to get x, we'll need to divide by minus 3. Now if we divide by a minus number, we have to swap the direction of the inequality. So x is less than 2, and that's our answer. So to draw this on a number line, we draw a circle above the 2, and it's left unfilled because x cannot take the value 2. And we draw an arrow to the left because we want to show all the numbers that are less than 2. In question E, we have 4 minus 2x all over 3 is greater than x minus 7. First thing, get rid of all the fractions, so multiply all the way through by 3, and we'll have 4 minus 2x is greater than 3x minus 21. Now if we add 21 to both sides, that will give us 25 minus 2x is greater than 3x. If we add 2x to both sides, we end up with 25 is greater than 5x. Now if we swap the sides, that gives us 5x is less than 25. We have to change the direction of the inequality if we swap the sides. Dividing by 5 gives us x is less than 5, and that's our answer. So, to draw the diagram, we have the number line and we put a circle above the 5. The circle is not filled because x cannot take the value 5. And we draw an arrow to the left because we want to show all the numbers that are less than 5. In question F, we have minus 1 is less than 2x plus 3, which is less than or equal to 9. Now, we want to get x on its own in the middle, so subtract 3 all the way through. So minus 4 is less than 2x, which is less than or equal to 6. Now, to get x on its own, we need to divide by 2. So minus 2 is less than x, which is less than or equal to 3, and that's our answer. So we draw a circle above minus 2, and that's left empty because x cannot take the value minus 2. And we draw a circle above 3, but we fill it in because x can take the value 3. And we draw a line between those two because x can take any value between minus 2 and 3. In G, we have minus 3 is less than or equal to 7 minus 5x, which is less than 27. Now we want to get x on its own in the middle. So we're going to subtract 7 all the way through. This gives us minus 10 is less than or equal to minus 5x, which is less than 20. Now we want x on its own, so we'll divide through by minus 5, and that gives us 2 is greater than or equal to x, which is greater than minus 4. Now because we've divided by a minus number, we've had to change the directions of the inequalities. Now 2 is greater or equal to x, which is greater than minus 4, can be written as minus 4 is less than x, which is less than or equal to 2. And that's our answer. So when we draw it on the number line, we're going to draw a circle above minus 4, which is left hollow because x cannot equal minus 4, and a circle above the 2, which is filled in because x can equal 2. And then we join those two with a line because x can take any value between those two numbers. And that's our solution.